Okay, guys. So we didn't have time to finish this number 2 rate of work problems during class because we ran out of time. So I'm just making this separate video so we can walk through the class example, the example and the class practice. So you guys can so you guys know how to solve this type of problems in your homework. Okay, at first I didn't think it was necessary because the steps are pretty clear on the worksheet, but I'm still worried. So let's just do this. So number 2, rate of work problems. It says to solve problems involving the rate of doing things, we use the following concepts. So here they give us an example. Okay, so if John can clean the classroom in 5 hours, if John can clean the classroom in 5 hours, then that means every 1/5 hour, John can clean, every 1 hour, John can clean 1/5 of the classroom, right? So it's this part. Okay, because John can clean the whole classroom in 5 hours. That means each hour, John can clean 1/5 of the classroom, okay? Therefore, John can clean 1/5 times x, which is equal to x over 5 of a classroom in x hours. This should be pretty easy to understand too, right? If John can clean 1/5 of the classroom in 1 hour, then for x hours, John can clean 1/5. So this is how much of the classroom John can clean in 1 hour, and we have x hours. So 1/5 times x. This whole thing means how much of the classroom John can clean in x hours, right? So it's this part. So this is the basic concept that we use. Okay. So let's just look at this example. If it takes John 4 hours to clean the classroom and Peter 3 hours to clean the classroom, how long would it take them to clean the classroom together? So it says, if John cleans the classroom by himself, it takes him 4 hours. If Peter cleans the classroom by himself, it will take him 3 hours. Now, if John and Peter work together, how many hours would it take them? So we basically use the same concept. Okay, so we know that if John works alone, then it will take him 4 hours. And that means each hour, John can clean 1/4 of the classroom. Right? With the same logic, if Peter cleans the classroom alone, it takes him 3 hours, right? And that means each hour, Peter can clean 1/3 of the classroom, right? Now we're asking if John and Peter work together, how long would it take? If John and Peter work together, then we can see John and Peter as one person, right? So this new John Peter person, how much of the classroom can John Peter clean in 1 hour? John can clean 1/4, Peter can clean 1/3 in 1 hour. So if they work together, the new person, let's just call him JP, can clean 1/4 plus 1/3 of the classroom per hour. right? Now that we know JP can, so JP means John and Peter together. Okay, so JP can clean 1/4 plus 1/3 of the classroom each hour. Okay, so let's draw a picture here. So let's say this is the classroom. This is a classroom, okay? John and Peter, they can clean 1/4 plus 1/3, which is 12, which is, so this is 3/12 plus 4/12, which is 7/12 of the classroom per hour, right? So let's say this is 7 of the classroom. So in the first hour, John and Peter can clean this much of the classroom. So how long will they need to clean the whole classroom? That will be, if we see this classroom as one, this whole thing, right? Each hour, John and Peter can clean 7/12 of the classroom. That means we use 1 divided by 7/12, which is 12/7. That means if John and Peter work together, they will need 12/7 hours to clean the whole classroom. Okay. So John and Peter, they need 12/7 hours to clean the whole classroom. Okay. Now we can check if the answer is correct, right? So like we got our answer here, right? We can check. How do we check? So we know that John cleans 1/4 of the classroom each hour, right? And now we know that it will take them 12/7 hours. Let's check if the answer is correct, right? So in 12/7 hours, John cleans 1/4, because we know John can clean 1/4 of the classroom each hour. Now John cleans for 12/7 hours, which is 3/7 of the classroom, right? And for Peter, we know that each hour Peter can clean 1/3 of the classroom. Now he cleans for 12/7 hours, and 1/4. That will be 4/7 of the classroom. That means in 12/7 hours, John cleans 3/7 of the classroom. And during the same time, Peter cleans 4/7 of the classroom, which means if they work together, 3/7 plus 4/7. So this part means John and Peter work together for 12/7 hours. And we can see that the answer is 1, which stands for the whole classroom. So after the check step, we know that the answer is correct. 12/7 is correct, which means they take 12/7 hours to clean the classroom together. 12/7 hours, that's, I didn't do the math, but we can do it together. So that's 1 and 7, sorry, 5/7, right? And just do the calculation, just 1 and, oops, 1 and 5/7 times 60. Okay, so so 1 and 5/7 means there's 1 hour, right? So we know there's 1 hour plus 5/7 times 60. So this part is minutes, right? So we know it's 1 hour and something minutes. And the answer is given here. So 1 hour and 43 minutes in the classroom. So that'll be our answer. Okay. So let's quickly go through this class practice together. So it says Jones takes 12 hours to complete a plant maintenance check on an anti-submarine helicopter. Marco, when you see, this like the background story or whatever, you don't even need to know what they really mean because those are not important, right? Those are not important information. What you really need to do is to take all the information that you need out of this question and build a mathematical model. Okay, so that's what you really need to do. So the question says John takes 12 hours to complete a blah blah blah. You don't need to know what the blah 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 is. You just need to know John takes 12 hours to complete something, right? And you know that because Jones takes 12 hours, each hour she can complete 1/12 of the task each hour, right? That's how you get the information that you really need. And Marco takes 4 hours to complete the same check. So Marco takes 4 hours. That means each hour Marco can complete 1/4 of the task per hour, right? So we know the information here. And Jones had been working on a helicopter for 4 hours when Marco arrived to help him finish. Jones. Oh, Jones. Sorry, Jones is a guy. Right? Okay. Anyway. When Marco arrived to help him finish the job, how long would it take them to complete the rest of the job together? Let X be the time for Jones and Marco to complete the job together. So our problem is, by the time Marco arrived, Joan had been working on the task for 4 hours. Okay, so how do we solve this? We know it takes 12 hours for Jones to complete the task alone. That means each hour, so we know Jones takes 12 hours to complete this task. That means each hour Jones can finish 1/12 of the task, right? We did that part here, right? And we know that before Marco arrived, Jones had worked for 4 hours. That means before, I'll write it here. Before Marco arrived, Jones had finished 1/12 times 4 of the task, right? 1/12 here stands for how much of the task Jones can finish each hour. And 4 here means 4 hours, right? And that means before Marco arrived, Jones had finished 1/3 of the task. And that means by the time Marco arrived, they will only need to do 2/3 of the task left. Needs to be done. Right? So this problem is a little more complicated than the example that we just did over here, because here we don't have the, what is it? So for this example, John and Peter started working together, right? So we don't need to subtract the work that was already completed. But for this question, one person started working before the other. So for this question, we need to find the part of the work that was already completed, and we need to subtract that work from the whole task. So we can compute how many hours Jones and Marco would need if they worked together. Because when Jones was working alone, that part of time should not be included in the time that they work together, right? So we know that only 2/3 of the task needs to be done, okay? And we know that, so Jones completes 1/12 of the task every hour, and Marco completes 1/4 of the task per hour. That means if they work together, so if JM, let's say this is a new person, if JM works, sorry, if Jones and Marco work together, they can complete 1/12 plus 1/4, which is 1 plus 3, which is 1/3 of the task every year. Sorry, every hour. Right, 1/3 of the task each hour. And we know that only 2/3 of the task needs to be done. So we have 2/3 of the task. So let's draw another little diagram here. Okay. So we have this much task to be done. Okay, that actually I will make this more clear. Okay. So we have this much task to be done, right? And this is 1/3 of the task. Okay. And this part of the task was completed by Jones alone. So before Marco arrived, Jones had already completed this part. So Jones alone. That means when Marco arrived, only this part of the task needs to be done. And this is 2/3 of the task. So we have 2/3 of the task that needs to be finished, right? And when Jones and Marco work together, they can finish 1/3 of the task each hour. So I'll just draw here. That means, okay, so let's say this is another 1/3 of the task. And this takes 1 hour. This is another 1/3 of the task. And this takes another 1 hour. So we don't even need to use any computation, right? This is a very straightforward way to figure out how many hours they will still need after Marco arrived, right? And the answer is clearly 2, because 1 hour here, 1 hour here, right? But how do we actually calculate it? So we have 2/3 of the task here. Each hour we can do 1/3, right? Divided by 1/3. 2/3 times 3, 2 hours. So that means, so I will just summarize this problem again. So before Marco arrived, Jones had been working for 4 hours. And Jones working for 4 hours completed 1/3 of the task because it takes Jones 12 hours to complete the task. That means each hour Jones can complete 1/12. Okay, so 1/12 times 4, that's 1/3. That means by the time Marco arrived, there was only 2/3 of the task that needs to be finished. Okay. And because Jones takes 12 hours to complete the task, which means every hour Jones can finish 1/12 of the task. And it takes Marco 4 hours to finish the task, which means each hour Marco can finish 1/4 of the task. So when Jones and Marco work together, they can finish 1/12 plus 1/4 of the task, which is 1/3. Okay. So each hour, Jones and Marco can finish 1/3 of the task. And we only have 2/3 of the task that needs to be finished. 2/3 divided by 1/3 is equal to 2 hours. That's how we solve this problem. Okay. So this is pretty much it. I hope it's helpful. So next week, there will be no new class because there will be a review session for your exam 1. Okay. So good luck, guys, and I'll see you this Saturday. Okay, bye-bye.